So today we're going to talk about our model, which is about collective emotional response during frequent repetitive reward-based gaming. And what we did is we constructed a third order organizational learning model for emotion-based skill building in joint gaming. We're first going to talk about the background, which means we're going to talk about frequent repetitive reward-based gaming. What is it actually? Then we're going to use organizational learning, explain why we used it. Then we're going to move on to our design, our simulations, how we evaluated it, and then the discussion. So first, the background. Well, the amount of multiplayer gamers has increased over the years. We were really shocked to know that almost 2 billion people in 2015 already gamed. That means 25% of the global population. And it's still increasing. In 2023, it's expected to be 3 billion people. And for this project, we use the term frequent repetitive reward-based gaming. And this is basically online gaming in which you get rewards based on achievements. So working together really makes getting these achievements easier. So basically what it is you play in a group and you have a shared goal. So for example, to conquer flags, which you can see in the screen. And this is possible through teamwork. Teamwork makes it very easy. And the two actors within a squad, they call it a squad when you play in a group, they communicate to each other and they learn from each other, especially when they play close to each other. And that's why you are in a squad, which you can see in the circle. And we made use of organizational learning. And in this context, it means the squad can receive information from actors and the actors can receive information from the squads. So basically, to make it a little bit easier, let's say Joy and I are childhood friends and we are gaming and we are playing a game that we have played for years. So if I would say to Joy, the enemy is at the yellow barn, Joy would immediately know where the yellow barn is in the game. So that is about that I am good at communicating to Joy where everything is. I could have said the enemy is there and Joy wouldn't know where the enemy is. But because I said yellow barn, he immediately knows. So I know the game and therefore my communication skill is good. Then you have Joy. Joy also needs to know what the yellow barn is. So that means that he needs to be able to listen properly and know what I mean by that. So that is the receiving information from the squad. So basically, the setup for us was we have actor 1 and actor 2, Haley and Alice, and they are both independent actors. And then we have a shared model, which represents the squad formed in-game. And you might think, why would you use organizational learning if you learn from each other directly? Well, that's because you have two types of communications, as I just said before. And in the games nowadays, the squad can earn points. So these points come in through teamwork player activity. And these are independent from the points that Joy and I would make when we would defeat enemies in the game. And it only works if you have teamwork activity. So defeating an opponent together, for example. So then the shared model gets points. Then you have the shared to player part. Well, being in a good squad leads to privileges that aid in reaching the achievement in a game. So for example, with the game that I just showed, if you get a lot of points, you can unlock a better character to play as and thus reach your achievements faster. So there are really two reasons to use organizational learning in here as well.
So I'm going to briefly talk about the design. We make use of 5 combination functions: the ID function, which follows the input, and a logistic function, which creates an S-shaped curve. In step mod, we created multiple intervals. The step ones, which created one big interval. And lastly, we used the Euclidean function to create a static value below 1. This resulted in a conceptual representation. First, I'm going to describe the base model. The base model consists of 3 individual networks, the 2 individual actors, as well as the shared model. The starting node of each network is the encounter rate. This is the encounter rate of either the shared of the 2 together or the one individual, how often you encounter an enemy or objective. When this happens, this leads to the concentration rising. When the concentration rises, the skill of the actors gets activated. When this happens, they get achievements. And when they do, they become happy, which creates a positive feedback loop back to the concentration. Getting achievement also has an inhibiting factor on frustration, which has a negative feedback loop on the concentration. The frustration of each actor is also affected by an external factor, the frustration builder. This frustration builder activates frustration, which again leads to a negative feedback loop to the concentration. In literature, we really found that emotions don't really have an influence on the skill of a player. However, they can influence the concentration of players. And concentration, in turn, leads to the activation of the skill of that player. Then, in the first adaptive level of the model, we have the wait state of each process previously described. So, for example, in the top left, we have the WSEC state, which is the wait state of the shared model from the encounter to the concentration. Each of the 6 smaller networks represents one of the process, and each of the shared wait state is connected to the wait state of the individual actors, as can be seen by the arrows indicated to and from shared model to the smaller networks. Then for the conceptual representation of the second adaptive level, this is the level that really connects the 2 actors to the shared model and from the shared model back to the 2 actors. So we have the WWH state and the WWA state in the middle, and the top middle, which is affected by 2 speed factors as well as the communication. So this really represents how well the 2 actors communicate to the shared model. And then beneath that, we have the WWH state and WWSA state, which is how well this squad communicates back to the 2 actors, which is affected by the listening factor. Then this is the overview of the entire conceptual representation, including all the connections between the 3 levels. And with this picture, we really wanted to make it clear how complex this model was in relation or due to all the connections. And for those who are interested, we also included the role matrices and more role matrices. Now I'd like to give the presentation back to Harry.
Thank you, Joy. So we did 3 different simulations, and these entailed around communication and listening. So first we have good communication and good listening, which is what I just described when I was saying that Joy and I were childhood friends and we really know the game well. So we are able to know what is in the game, and we are also able to understand when, for example, Joy says the enemy is at the yellow barn. Then we go over to bad communication and good listening. This would happen if Joy and I are childhood friends. We are able to communicate well with each other, but we are playing a new game. We don't know the game, so we don't really know whether there is a yellow barn, and if we say yellow barn, where that place is. So that would be bad communication, but good listening. And then finally, you have bad listening and good communication. And this could be, for example, for all of us who had a childhood gaming, someone walking in the room with a vacuum cleaner when you are gaming and talking to someone else. And don't be shocked. This is a very big image, but what it basically shows is that in our model, the results were that the frustration initially rises because you don't really have skill, you don't really have achievement, so your happiness really doesn't go up. But once that happiness is starting to go up, as well as the achievement, you see that this frustration is going down. And this is a good thing, because that means that you build your skill around the fact that you get achievements. And yes, it is true that the skill builds faster than the achievements, but this is because you learn a lot during encounters as well. So it's really a compounding effect that really goes fast rather than the achievement rate, which progresses a little bit more, well, not linear, but more steadily, to say that. So yeah, you see every line going up, and now we go to bad communication, and you see that everything is very moving. And you also see that frustration is ending up way higher as well. And this is because we are not able to communicate well to each other. And this really shows the core of our model, in the sense of that there's no happiness because communication is really important. Communication, you need communication to listen well. Okay, no, not to listen well, but to get something out of being able to listen well. And what you see here is that the skill and the concentration are not really efficient. They don't really go up as compared to the other figure. And then we finally have the bad listening and good communication. And you see here that everything is a little bit the same as the optimal situation. But in the case of Alice, the bottom actor, you can see that she doesn't really have high concentration, high skill, because she has a disadvantage on her side. And you can see this also in the frustration curve. She flattens out her curve in frustration. And what this means is basically that she was so bad in the beginning that she never had the chance to recover from it, which is sad. But this does happen in the world of gaming. You start with a game that is not really your style, and you are not becoming proficient at it, especially if you cannot learn from each other. Well, let's go on to the evaluation. We thought for originality also, and for the interest of our research, we wanted to look at the emotion ratio. So we compared happiness to frustration. We divided happiness by frustration, basically. And what we saw was basically an alogistic curve, as you all saw in the assignments as well. And this is quite logical if you think of it, because we made use of a lot of alogistics. And when we looked at the different situations, we saw that some lines were flatlining. And this would not be in line with the findings in literature, especially when it comes to worsened communication, optimal listening, because what you see is actually, if you move down to the level of 0.0003 instead of 2.0, that you do have the same curve. So the model does want to do the same, but it does not in the end. So first we verified it just to make sure that we did the right steps. So we just computed the values and we looked at the differences, and these were quite minimal actually. So we were really happy about that. And then we performed tuning, and the tuning was performed to adjust happiness, the ratio between happiness and frustration. And for that, we let the tuning matrix include frustration and happiness parameters. So 3 for each, because we had the shared model, the independent model, and another independent model. And then the tuning parameters were a lot: the weights of achievements to happiness, the speed of all happinesses, the alogistic values of all happinesses, the initial values of all achievement to happiness weights, and the contextual communication and listener weights were used and functions. And what we saw, what we did was actually we made the tuning matrix based on the HF ratios that we saw in the optimal communication curve. So, but what we did was we also thought like, okay, but what would bad communication mean for this curve if everything went logical? And then we thought, okay, it should end a little bit lower because people are able to communicate less well. So that would mean that frustration would be higher and happiness would be lower in the end of the graph. So we lowered the graph a bit and we slowed it down a bit for the tuning matrix. We found a quite low RSME of 0.1379, which is quite low for as compared to all the other tunings that we had to do. And we got this graph out of it. And it's really funny because it looks like the optimal situation, right? But the funny thing is the tuning model actually made the situation become worsened communication and listening. So it made it and worse communication and worse listening, but it looks like the optimal curve. So Joy and I were thinking like, okay, well, maybe our mission was successful. We got all the happiness levels up again, but it looks like the same model. So then we also thought, like, maybe it could be that we just desensitize the communication and listening variable, which is also a good thing, because then you are able to experiment with it more, because there's a bigger range in which you can change the values. So we just zoomed in on the adapted happiness and frustration, and we compared it to our predicted happiness and frustration, and we saw that the curves fitted quite well, which is to be expected with an RSME of 0.1379. So yeah, we were happy about that too. And we compared the HF ratio to the optimal HF curve, and we saw that they were around the black line, and they followed the same trend a little bit. So we were quite content. So to move on to the discussion, our conclusion is that a successful model was created for frequent repetitive reward-based gaming that makes use of organizational learning and simulates emotion responses in relation to skill